Good afternoon, I'm Diego Reina, and this is my final homework. So the objective of this homework is to create a node to drive the simulated robot in a square path of a side length of 2 meters. The closed loop controller must be robust, the controller must define the road velocities, and it must take into consideration perturbation, nonlinearities, and noise. Some of the metrics for success for this simulation is that the controller will be capable of taking the robot through the square path and to a near point of its initial position. The controller is capable of handling the irregularities of the simulation, and the simulation is finished successfully after the robot completes its trajectory. So the main algorithm is using the values of angular velocities of the wheels. The current position of the robot is obtained by integrating these velocities using Euler's method for differential equations. Afterwards, the current position is used to generate an error between the goal of the robot and also the error between its orientation and where it should be heading. Both of these errors are then used in PID controllers, whose output is then sent through a twist message to the simulation. After the goal has been reached, a third PID is used to control the turning of the robot. The main subscribers of the program are of the node are puzzlebot one slash wheel right and wheel left to obtain the angular velocities of the wheels, the clock topic in order to maintain the simulation and the node at the same running at the same time, and it also publishes in puzzlebot one cmdbel to send the twist message of the velocity of the road. The functions that were used were the function avanza, gira, detente, main, and stop. The main and stop functions are the main functions of the program in which the while loop is initialized. Avanza is where the first PID is used in order to get the robot into the correct position. And afterwards, where the first two PIDs are used, and then gira is where the third one is used. Finally, detente only sets the twist values to 0. The libraries used were STDS messages, geometry messages, Ross graph, and NumPy. So these are the parameters of synchronization that were used for the PIDs. There's also a value for compensation on the first uh, that's trajectory, as it presented an irregularity that would change the trajectory and the end results. This is the code, the first definition of the callbacks for the subscribers. Then the function avanza, in which the first two PIDs are used. Then the function gira, function there afterwards. There were also a function called parameters, in which the parameters of the PIDs were defined in order to make the controller more robust, as it applies specifically for each one of the travels that it has to make. And this is where the compensation was used. Finally, the function stop, and this would be the main program in which first there is the function that there is first an if that would set the time where the program was started, and then this time was used as a delta or a differential of time. And finally, the main loop would be with a counter, and if the counter is still less than 4, then the function parameters is called. And while the distance between the distance of the robot and the distance of the goal is less than 0.01, the difference between them. The function avanza is called. Afterwards, the function detente is called. The angle, and the angle of the objective angle and the current angle of the robot are updated, and then the function gira is called. Afterwards, the values are reset, and the counter is upped by 1. So the conclusion of these simulations, the results of the simulations were on the most part successful, as the robot managed to come back to a point near its initial position, even though there is still a lot of work to be done with the synchronization of the PID controllers, as no clear methodology was used in order to deal with the irregular conditions of the simulation, as most of the values obtained were obtained by trial and error. Another disadvantage of this method used to synchronize the controllers would be that they are limited to this simulation and have shown that even though they were designed to be robust and endure irregularities, they are not 100% adaptable and were shown to be given the trajectories wrong and given an end result incorrect.